Okay, so the first thing I'm going to ask you guys to do today is pull up Module 5.3. And if you, at this point, haven't looked at that yet or haven't printed it or maybe pulled it up so you can write on it, you may want to pause this video and print Module 5.3 so that you can write on it. Completely up to you. Or you can just listen and watch and see if you can understand it. You also probably going to want a calculator out so you can do some of these problems along with me, since there's not going to be somebody in class doing it for you. So don't be lazy and actually do the calculator part. So it'll help you guys understand it better. Okay. All right. So once you have that, you can continue the video. And I'm going to pull it up on Word here so I can actually write on it. But today we're looking at the difference between the molecular and the empirical formulas. And let me make this bigger. Okay. All right. So the molecular formula is typically the formula that we normally use when you talk about any kind of formula, like when we talk about sucrose or glucose or water or anything like that. We're talking about the molecular formula. The molecular formula, and I'm not going to write on here because it's actually hard for me to write like sentences, so you can add this in. But the definition I would use for molecular formula, it's the formula that gives the exact number and types of atoms that are present in the compound. Okay. And then, so again, it gives the exact number and the types of atoms present in a compound. And then the empirical formula is similar to that, but it's the reduced version. So the empirical will be the reduced version of that formula. All right, so the next question says, can they ever be the same? So can the empirical and the molecular ever be the same? So if the molecular tells us how many would be there, and the empirical is when we reduce it down, can you think of any instance with this situation where they'd be the same? Okay, so one that probably is really common for you to think about because you should know it off the top of your head is water, right? Water is H2O. So H2O, when we reduce it, would just also be H2O, right? So that's our first example here. Let me see if it'll let me write correctly on here. So the answer is yes, and a good example is H2O. See, I'm terrible with writing with these pens, so sorry. Just giving you a heads up. Okay, so let's take a look at this next thing. It says, for example, the widely used formula for glucose is what? You should know this from biology. I ask you this all the time. It's C6H12O6. Okay. And how would you classify that formula? Would we classify that as molecular or empirical? Well, it's clearly not reduced, so this must be the molecular. So typically the formulas you use on a daily basis are going to be molecular formulas. And then what would the empirical be for that? So if you take a look at it, we can reduce them all by 6, right? So it'd be CH2O. Another compound that we will use a lot this year that has the same empirical formula as that is acetic acid. And, oh, I don't know what just happened there. Sorry. Acetic acid. So acetic acid, interestingly enough, normally we write it like this, HC2H3O2. But if we could also write it like this, C2H4O2. The only reason we write it like this is to show it's an acid, right, with the H in the front. So anyways, you can see it will reduce down to the same thing. Okay, so take a minute and see if you can look at these molecular formulas for A, B, and C and come up with their empirical formulas. Go ahead and pause it and try it real quick before I show the answers. Okay, hopefully you paused it and you tried these ones, so now let's do it together. So on A, you should be able to divide them both by 6, so you should be able to get, it's just CH. Okay, that's A. And then for B, if you look at them, you can tell they can all be divided by 2. So it should be C6H2Cl2O. And then for C, they can all be divided by 2. So C3H8N, right? So no big deal. So that's the difference between molecular and empirical. Do these problems get a little harder? Of course. It's chemistry. Okay, so let's take a look at the rest of it. So we're going to use this formula up here, and it's a nice little formula where it's giving the relationship between the molecular formula and the empirical formula. Now, we already said the empirical formula is the reduced one. This N indicates the number of times it's been reduced, right? That's what that is, number times reduced. So if we multiply it back by the number of times it was reduced, you'll get the molecular. Makes sense. All right, so the little formula that I use is N equals me. If we want to figure out what that number is that it was reduced by, you're going to put the N is equal to the molecular mass over the empirical mass. And when I'm talking about that, I'm talking about the molar mass. We've run that recently, right? So this is the type of question I talked to you guys about in class. We have a white powder. It's been analyzed to have the empirical formula of P2O5. The compound, we know, actually has a molar mass of 285.855, or 285.88. What is the compound's molecular formula? Okay, so we're going to use this N equals M over E, right? So we know the molecular formula, that the compound molar mass, that's the molecular. So N is equal to 285.88 grams. And then we're going to put that over this. This is our empirical, so we have to get the mass of that. So I know phosphorus is 30.97. Hold on, let me get my little calculator up here. Where's my calculator? What happens when I bring my phone out on my calculator? Okay, so I got 30.97 times 2 plus 16 times 5, because that's the mass of oxygen. So I get 141.94. Oops. Stop it. I don't want the eraser. See, this is what makes me, oh my gosh, now it doesn't like me. Okay, well, we'll just wait until it's ready. Hope you guys are all doing good while we're waiting for this. Oh, look, Word is restarting. Good. Wow, let's see if it's there. That's cute. This is why I love Word. Here it is. I think it's right here. Nope.